Hello, my name is John Sayer, Technical Marketing Manager, Civil Infrastructure here at Autodesk. Today I would like to take you through a product demonstration of AutoCAD Civil 3D. The goal for today is to demonstrate the power of AutoCAD Civil 3D when working on a roadway project. Throughout this demonstration, you will hear me speak of some of the pain points that you might encounter when working on a project of this nature. So that being said, let's get started. To give you a bit of background about this project, we've been asked to design a traffic relief route for an area that has heavy traffic at peak hours of the day. This relief route will give people the option of bypassing this area and at the same time being able to access a future development. So the new roadway will not only help with the traffic problem, but also help open up access to a new development. So let's start to establish some existing conditions. There are a couple different levels of existing conditions that we'll talk about. One being more of a preliminary look, so we'll use GIS data to look at those existing conditions. And the other one would consist of a detailed survey where we had a survey crew actually go out and pick up field to finish line work. We've got some existing GIS data that we've found and gotten from the local municipality. We're going to drop that information in and we're going to use Map 3D to do that. Map 3D is inside of Civil 3D as a GIS tool. So let's go ahead and show you what I'm talking about. So I'm going to open up Windows Explorer here, and I'm just going to simply grab the information that we received, and I'm going to drop it in on the screen. Now here's all the information. Now it looks like a lot of data, so we could confine this data just a little bit. What we're really worried about is where the proposed center line is going to be inside of this project. Now, why did I bring the GIS data in? So that we can see if we're going to have problems with running into utilities, going through a wooded area that nobody wants to disturb, maybe actually going through a house. We don't want that. So this will give us a good idea of where everything lays. Another piece of information that we might want would be an aerial photo. So I'm going to go up and I'm going to turn on, using Bing Maps inside of Civil 3D, an aerial of the project location. So as you can see, we do have some of the some dots that we're not quite sure what they represent. So an easy way to figure that out would just be to open up the Map W space, or actually the Map task pane, and we can see what each entity represents. So this particular entity is got it's a green color, so we could just scroll down and look for that color, and we've got a couple different green colors. Easier way of doing it would just be to select it, right click and go down to show data table, and it tells us what those are. So those are traffic stop signs that we got sent to us that was in the GIS data. So might not sound like it's that big a deal. There's a stop sign there, but if we're running a road through it, they're going to have to remove the stop sign, and that's just going to be something that's added to the cost of the project. So the whole idea behind this project is to run a road, the relief road, from this highway right here before it gets to the interchange, run it through to an existing road here in town. As you can see with the Bing Maps, the tighter you zoom, the better the image is. So we're going to have a center line that touches this road and touches this road. So now that we've kind of established what is out there structure-wise, so let's go ahead and bring in a surface so that we can start to look at the vertical elevations and see what kind of problems we might run into there. So I'm going to do that. We've downloaded a DEM file. We're going to create a surface from a DEM to get that existing condition. So we'll go through and we'll let that go ahead and generate. Now these surfaces can be downloaded from USGS. I'm sure there's other places out there that you're used to getting them. USGS is a good place to go for that data. So we'll wait for it to generate. So you can see that the surface with our map behind it, you can't see the surface very well. And right now what we want to do is we want to change the style to reflect what we want color-wise so we can see the contours a little better. So I'm going to select the surface, and I'll go ahead and go down to Surface Properties. This is where we start to talk about styles just a little bit. In styles, what a style does is it's how something looks. So our surface, how our surface looks. If I go in and edit that style, I've got a lot of different parameters I can change, but for now the major and minor contours are what I'm concerned with. So the major contours will be red, the minors will be cyan. So if I hit OK and OK, it'll go ahead and change. This is actually a tighter set of contours. It's just reflecting a tighter set of contours, meaning it was set to 2-meter and 10-meter contours. Now it will be set to a 1-meter and 5-meter contour. So as you can see, that the change in color makes it a little bit easier to visibly see what the contours look like and see where the limits of our surface are. So from this data, we have come up with a proposed roadway alignment, meaning horizontally where we think that the roadway will lay. And we've done this through not just us, the civil engineering firm ourselves doing it, but we've collaborated with several people to talk to them about where they think that this road should be located. So a traffic engineer maybe, definitely the city or municipality. We've come up with that location. So we're going to import that location, and instead of dragging and dropping the GIS data on now, we've got the location out in GIS form, so we're just going to import that location. So I'm going to type map import, and I'll select my center line, and all of this is okay. I'll hit OK, and there is our location. As we can see, we get close to this shaded area. So we need to be wary of this shaded area because this shaded area actually represents a contamination zone. So we need to keep that in the back of our mind whenever we're doing our design. So let's see what this roadway would look like vertically if we were to just do a quick profile from this surface and see what kind of vertical problems we were going to have preliminarily. So I'm going to shut off my map, and I'll select my center line, and I'll just run a quick profile. Now again, this is just a quick profile so we can kind of see what's going on. So we'll zoom all the way out, and we'll just set this profile in over here to the right. And we can see from this profile, this is pretty flat. All right, so you can see the actual center line here in the profile, and you can see that again, it's GIS data, so it may not be the best surface in the world, but it gives us a look at how that particular grade would go from one end of the road to the other. So now that we have our location, we can go ahead and narrow down the scope of our topo that we're going to have the surveyors go out and get. And they've gone out and they've located topographically some of the structures that are inside of the actual area that we need. So we don't need this big giant topo that we've got that we use preliminarily, but we're going to go ahead and narrow it down to a detailed topo of just this area. We might actually do an offset and tell them to pick up everything inside of 100 meters on the north side and 100 meters on the south side of the roadway alignment, just so that we know we have enough. And I think that's probably going to be good enough for the topography for the design road. So we'll go ahead and look at what they've picked up. So I'm gonna go ahead and turn off the DEM surface that we got from the GIS data. And I'm gonna go ahead and do this. I'm gonna turn back on my aerial map just so I can see it come in. And that way it'll give you an idea of what's going on in the background here whenever the topo comes in. So we're going to bring in the field to finish line work using a survey database. I've got a survey database here that I built called Civil 3D Demo, and I'm going to bring in their point file that they used or that they shot in the field, and it's going to create what's called field to finish line work. That field to finish line work, it's going to enable Civil 3D to actually draw some of the features that they picked up in the field. I'll show you what I mean. So I'm going to create a new network, and we will just call this existing survey. And we'll go ahead and import the point file that they gave us. So I'm going to select my existing ground surveyed point file. This is just a TXT file. Go ahead and open it. And be sure that all of my defaults are set here in my import point file dialog. So I'll go down and check through. We're using our figure prefix database that I generated for this topo. And everything looks to be good, so I'll hit OK. And what it's going to do is it's going to bring in the points that they shot, and it's going to draw the line work that they coded in the field. So you can see here there's a lot of information in this detailed survey. So we should have plenty of information to do our alignment and profile here in just a second. So not only did it bring in the points, but it also brought in the line work for the roadway on either side. So it also brought in the pavement, or actually the edge of shoulder. Brought in the sidewalk that we're crossing down here, the trail or path. It brought in a roadway crossing here, so you can see the line work is already generated. So what we're doing is we're reducing the amount of time that it takes the inside crew to actually show the line work that was picked up in the field by the surveyor. So it automatically draws those lines for you if you've coded it correctly in the field. So we've got our line work. Now I don't want to necessarily see all of these points all the time, so I'm going to generate a point group, and I'm going to call it no points. All right, and in this point group, I'm going to go ahead and give it styles of none so that it won't display anything, and I'll include all the points. I'll hit OK. So when I do that, it shows the actual symbols of the trees that came in. So if they'd have picked up any of the utilities or anything like that, maybe gate valves, maybe a sewer manhole here and there, it would have shown those symbols. The symbols would actually show up now and you could see them. So the next step is to go ahead and generate a surface from the topography that's come in from the surveyor. So we can see the line work. You can see it real well with the points set to that no points point group. And we can create an alignment and profile from this center line so we can start to do some detailed design. First off, we have to generate that surface. So I'm going to go ahead and create another surface. I'll call it existing survey. And we will set that to a style and hit OK. So how we're going to populate this surface is we're going to generate a point group that is only specific to our existing ground. Okay, so we're going to create a new point group. We will call this for existing topo survey. And we will go ahead and tell it to include everything and exclude anything with an elevation matching 0. So if we look at our point list, we can see that that'll kind of take out any of the 0 elevations that we've got in our points. So we don't have to worry about it generating topography or contours for something that it shouldn't. So I'll go ahead and tell it OK, and it'll populate that point group. And now we can see the points again. So let's go ahead and go to our surface, and I'm going to define it by my point group. And I'll go ahead and select that point group I just built for existing topo survey. And it generates our contours. Again, this is a relatively flat survey, a relatively flat set of data. Our contours are kind of, there's not that many of them. So we can actually change the style again for that surface. We go to the surface properties, and we can change that style again, and maybe to a smaller style, maybe a 1/2 meter, 2 meter style. And again, let's go ahead and look at that and make sure it's the colors that we can see. So I'll go ahead and change those to the majors to red and the minors to cyan. Again, if you have a company template, then that company template will already have these styles set up for you. So it'll basically just be opening up the surface and changing the style, and it'll look the way that you want. This not only helps you when you're trying to represent something in Civil 3D, meaning the style is already built for you in the company template, but it also standardizes the look for your company so that you can make standardization a little bit easier. So I've got some contours here that are traveling outside of my surface area, so I need to kind of tighten up the surface a little bit. So I'm just going to draw a real quick boundary so that I can kind of tighten up the contours so that they're not drawing out and being represented not necessarily wrong, but there's just not enough information out here point-wise to actually generate a good surface. So I'm going to just draw just a loose boundary around it. You can make this boundary as tight as you want, and we can actually adjust the boundary here in a second, and it will automatically update if the boundary is not tight enough for us. So we're getting here to the end. All right, so we have our boundary. So we're going to go ahead and add that boundary as an outer boundary. And what that's going to do is it's going to tighten up our surface here where we don't have the amount of shots that we really need to represent a good detailed survey. So I'll just go ahead and leave these default and hit OK. And our surface is now tightened up. So if I was to pick that surface now, I could look at it in our object viewer, and we could see how that surface looks. All right. So let's go ahead and turn off our points right now. So I'll move no points to the top, and it takes on the characteristics of the no points point group. If you remember, we generated that so that we could turn our points off in just a couple of clicks instead of going through and trying to filter through layers. So I want to actually add some contour labels to this location right here. So we'll go up and we'll add some annotation. So I'll go ahead and go into my ribbon and select annotate. And I'm going to add some surface labels. So the type of label I'm going to add is a contour single to start. I'm just going to leave the defaults for the styles. I'm just going to select my contours. I'll zoom on in. All right. That's just one way to add the surface labels. So if I grab that label, you can see I have some grips, so I could actually stretch this out just a little bit, and I can move that label anywhere I want here on my surface contour line, and it updates. Now there's another way that I can add those. I can actually go in and I can add by contour multiple, and I can pick the surface that I want to label. I can just drag a line across, and everywhere that it crosses a contour, it will label. So I could run all the way up to the top of my topo, and now all of them have at least one label on them. So you can do this as many times as you want. And the great thing about it is that if you grab one of these labels, you get this contour label line. All right, that's highlighted, and I can grab a grip marker and I can move the contour labels according to where I move that grip marker. So you can see those moving and updating. All right. Now that I have my surface created and my contours labeled, I can go ahead and I want to start to look at my horizontal alignment that I brought in from my GIS data that everybody had talked about and agreed on that this would be a good location for the road. So I'm going to start to kind of drop some things back because I don't necessarily need them right now for the part of design where we're at. So I'm going to type map W space, and I'm going to go ahead and just shut off some of my GIS data. And you can do this simply in the map task pane. You can just turn off the information by taking a check mark out. And what it'll do is it'll kind of free up my my model. Okay, I'll go ahead and I'll turn off my map for right now. And I've got my detailed survey, and you can see the tree symbols that it brought in. So I've actually had the trees located. It's got the parking areas here, or a parking area here that they picked up in the field, a road. Again, some of the asphalt areas that you see here. This was an old, looks to be an old airport. You can see the outlines that it came in from the detailed survey. So I've got the information that I need, so now I can start to locate everything horizontally and vertically for my design on my road. Okay, so before I start to do any horizontal and vertical design, what I want to do is I want to check my drawing into the vault so I can start to actually allow others to utilize some of this information if they're trying to do some other design on this road simultaneously. So I'm going to go down, I'm going to create a project in the vault, and we'll call this new roadway project. And you can call this, you could have a job number, anything you want to describe this project. I'll just go ahead and hit OK. And you'll see here that I have a plus sign next to projects here in my tool space. So here's my new vault project. So then I could go ahead and just select check in. I'll go ahead and select my project, and I'll just leave, for right now, I'll leave it in my drawings folder. This is going to be, this drawing will go and be checked into my drawings folder. And this is the information that's going to be pushed to that particular project. It's going to bring my surface. Whenever we check this in later, it'll take all the alignments and profile information and everything for our project and put it in the vault. So I'm going to go ahead and hit next. I'll select my surfaces to go in, and I'll let it go ahead and check the drawing in. So once our drawing is checked into the vault, I can go ahead and start some design. So I'm going to go ahead and I'm going to create an alignment for my center line of my road. So I'm going to run up and I'm going to select create alignment from objects, select my object, and I'll give it a name. Again, this naming convention that you use, it can be anything. We're just going to call it a new road. We'll leave it a centerline type of road, and we'll drop down and make sure that we've got our style correctly set for our labels. So we want to be sure that we select major, minor, and geometry points for this particular roadway. So I'm going to go ahead and take the conversion options off, and I'll hit OK. Now, this is where we're going to start to talk about a little bit of the dynamic functionality inside of Civil 3D. So say that our roadway, I didn't necessarily meet exactly where I needed to here on the edge of pavement. So I could actually select my alignment, and I'll just grab and move it back just so you can see it updates all the stationing along that alignment whenever you grip edit that alignment. Now, I'm not on my initial location, but again, that's okay because the alignment is going to represent the center line. So I can grab the endpoint of my alignment, and I can actually set it perpendicular to the road. That way we'll have a nice 90-degree intersection here whenever we get to that level of design. But the point is that all of your stationing and labeling updates just by a simple grip edit of that alignment. So that's where we start to talk about the dynamic functionality inside of Civil 3D, and we will definitely hit on that more as we go along in the demonstration. So all of our labels and everything come in. Again, this is controlled with a style, so you can make any of these labels look like what you would have for your company style, so your company look. So we've got our alignment. Let's go ahead and start to look at this vertically. So if I go up to profile, I'm going to drop down and create a surface profile, and we'll select our alignment. We've only got one in the drawing. I'll go ahead and tell it I want to add my existing surveyed surface. I don't want my GIS surface. I just want my existing surveyed surface. This is what was collected in the field. I'll go ahead and add it, and I'll hit draw in profile view, and I'm going to leave all of this default except for my profile view style, and actually that's the one I wanted to use, so full grid. I'll hit next. We can control this by station range or give it a user specified range. We're just going to leave it automatic for right now. We're going to go ahead and accept the defaults throughout the rest of this dialog, and I'll hit create profile view. And I'll stick that profile out here to the side. So again, this center line is just a little bit hard to see, so I'm going to grab that center line. This is what it's sampled for our existing ground. And I'm going to go to the actual profile style, and let's just change that to a different color. Let's change it to like a green. And you can see it updates that quick. Now again, these styles would be something that you would want to set up in a company template. Then the line work would come in and look the way that your particular plan set or your company's plan set needs to look. So we're going to go ahead and throw a proposed grade on here so that we can start the design of our corridor. So I'm going to go up and get into my profile creation tools. I'll select my profile view here, and we're just going to call this finished grade. Again, whatever you name this, that's totally up to you. Today we're just going to call it finished grade. We're going to accept the defaults for the rest of the dialog. Our design profile is what we want to show for our actual profile itself, and our complete label set is the label style that we want. So once you select OK, we can go up in our toolbar and we can start to draw some tangents. So I'm going to select where I'm tying in my existing roadway, and I'm just going to throw in a profile. So I'm going to come down to there. And again, this can be done to a lot more precise level, but because this profile is so long, we're just going to start off just by adding them in by picking down through the profile view. And I will snap to the end. Now, I didn't get it all the way to the end of the profile, so that's not a big deal. We can just select the finished grade, and I can grab the grip edit marker, and I can then snap it to the end. Now again, notice what that did. If we look at our label here, if I pull that back, the label moves and the stationing updates. So everything is dynamic to that profile. I'll go ahead and snap back to that end. And now we've got our vertical in there. Now, again, that vertical can be laid into an exact station and elevation. There's a definite easy way to do that. It's just, again, for the length of profile and the amount of time that we have today, we're gonna just lay it in by hand. So I can grab each PI if I want, and I can move them to a specific location, and the labeling updates. I can also put in vertical curves. So if I want to put in a vertical curve according to, say, maybe length, I can grab the incoming and outgoing tangents, and it asks me to put in either a radius, pass through, or a K. So I'm going to just do these this set of vertical curves with a 200-foot radius. I'll pan on down. I'll select the next two tangents and say 200. Come to the next tangents, and I'll say that's a 300. We'll put in a 300-meter curve there also, and a 300 at that last location. Actually, there's one more. We'll say that one's a 300-meter curve. Now, you could have put those in by K factor, and it would have put the appropriate length in for the vertical curve according to K. So we've got all of our labeling for our profiles, and here's where we really start to see the dynamic functionality of Civil 3D. And I don't know if there's a good spot that you just instantly start seeing it, but the more that we start to design, the more the dynamic functionality really comes into play. So if I grab this vertical curve here and say I want to move it, if I grab that grip marker in the middle, I can move it 360 degrees. So if I move it to here, all the labeling updates. I can grab it on this from this arrow here, and it will drag it out according to the grade on the incoming tangent. Same thing on the other side. If I grab this grip marker here, it will update according to the outgoing tangent slope. And again, I can grab the center marker. I'm now in a fill situation, so you can see the existing ground and the proposed grade. If I wanted to put that in a cut situation, I just bring it down below the existing ground. Now, this can be done whether you are at this point in design or if you've got a completed plan set. This updating can still happen because everything that is reading this profile will actually update regardless of whether it's in a plan set form or in this stage of design. So we've got our finished grade. So now we need to go ahead and add an assembly so that we can push that down our alignment. So I'm going to close this, and I'm going to go ahead and create an assembly. And we'll just call this new road. Again, you can name it whatever you want. And we'll leave everything default here. And I'll go ahead and hit OK and just select where I want my marker to be. So this is the centerline marker for our roadway, and we're going to attach our pieces of our road as our sub-assemblies of our road to this assembly marker. So I'll go ahead and open up my tool palette, and I'll pick the lane that I want to use. So I'm going to go to the Lanes tab, and we've got a 6-meter wide lane that we want to add in on this assembly. So I'm going to go down to my properties, and I'm going to tell it the width of this is going to be 6 meters, and I'm just going to simply Actually, I got one more thing I need to turn off. Turn off my potential pivot, and I'll go ahead and select my lane. Now I came in on the left. That's the side that it said it was going to come in on. If even, I know that my lane on the other side is the same width, so I'm going to go ahead and just select my marker again, and it'll add that on the right side of my assembly marker. So we've got some curb that we want to add, so I'm going to go ahead and select the Curbs tab of my tool palette, and I'll select Urban Curb Gutter General. We're just going to use the defaults inside of this. You can stretch and pull this curb any direction you need to meet requirements of the municipality or the reviewing agency's code. So we'll just leave the defaults for today, and I'm going to select the outside edge of that corner there on my lane, and it throws my curb in. Now we're going to go ahead and build out the right side, and then I'll show you how we'll populate the left side. So I've also got a sidewalk that I'm going to put in. So I am going to change the inside and outside boulevard width. So we've got a grass area in there. So I'm just going to put a 1 meter inside boulevard width and a 1 meter outside boulevard width. Again, the slope, this is calling the slope for my sidewalk. So I'm just going to say that's at 1%. And I'll go ahead and stick that on the back curb. And you can see how the sidewalk is shown. Now I've got one more thing. So we've created design basically from the center line of our road all the way out to the edge of our sidewalk. So now we need to tell it what to do when it's going to slope to daylight automatically in the corridor. So I'm just going to pick the basic side slope cut ditch assembly, subassembly, and I'll tell it I want it to go 3:1 to start out for the cut slope and fill slope. And this is actually, this particular subassembly would actually put a ditch in for us automatically, but I'm just going to zero out the information for that ditch and add it to the edge of my assembly. So how do I get this information to the other side? I want it to be consistent on both sides, so I want it to be the same. So I'm just going to select the curb and everything past the curb, and I will mirror that information to the other side of my assembly. So now I have the assembly that I'm going to push down my center line of my road. It's going to read the vertical alignment of my profile that I generated, my profile at this point right here, and then the assemblies will sub-assemblies will take over and give us our finished product. So we now have everything we need to generate a corridor. So let's go ahead and create that corridor so we can start to look at this at the vertical design and make sure that we're balancing earthwork wise, things of that nature. So I'm going to create a corridor, and we'll just call this new road, and we'll make sure that our alignment is selected that we need. So our alignment that we want it to travel down is our new road. The profile we want it to read is our finished grade, and we'll select the assembly that we just built and tell it to target our existing surveyed surface, and we'll select OK, and our corridor is built. So we want to see a surface, finished grade surface from our corridor. So I'm going to select the corridor. I'm going to right click and go to Corridor Surfaces. Here's where we'll tell it to generate a surface from our design. So I'm going to go ahead and tell it to create a surface. We are going to tell it a different styles because it's going to be a different look. So we'll give it a 1 meter, 5 meter design. We may go back and change that or copy this style and change it to where you can see more contours. Matter of fact, let's do that now. Let's just copy this style and let's rename it 0.5 and 2, and take off the copy just so you can see how a style, one way of style can be built. We'll go into contours and tell it we want to change the interval. So I want to change the interval to 0.5 meters and 2 meters for the major interval. We'll change the color here. Again, we'll just change it in the style this time just so you can see it, and we'll make those all blue. Go ahead and hit OK, and our style is selected. Again, this would be in your company template, so you would just pick this style from your template. We'll give it a code of the top surface, so this is going to be the actual finished surface, and we will select our overhang correction to read the top links. We'll go ahead and add a boundary. I don't want it to go outside of the extents of the daylight on either side of the road, meaning wherever it touched existing ground from our design. So I want to add the corridor extents as our boundary. It will rebuild the corridor, and here is our surface. Now we can select that surface and we can look at it in the object viewer, and you can see that it does not have triangulation that goes across from curve to curve like we've had in the past. It's because of that corridor boundary. So right now we're at a good point. We could actually go in and we could look at an earthwork volume from the finished grade to the existing ground. Now if you wanted to go to subgrade, we could go back in and we could create another surface, and we can do that real quick. So we will create a corridor surface that will represent our subgrade. So this is going to be our new road. We'll just call it subgrade. We're not gonna give it a style. We're gonna tell it no display because I don't necessarily want to see the subgrade surface, but I want to pull my earthwork volume from that subgrade surface. So we're going to be using links, and I want to use my datum code for that link. I'll add it, and I'll tell it to follow the bottom links. This is going to give us a surface to subgrade, and we'll use the corridor boundary as the limits also, so that we don't get extraneous triangulation. And it generated my other surface. Now I can hover right here over my road, and it will tell me all of the different elevations for that for the surfaces that I have represented underneath where my cursor is just sitting on the screen right now. So I've got my new road surface, which would be the proposed road. I've got my new road subgrade, which gets us down below and takes out the pavement thicknesses and everything. And this is the surface that we would want to use for our earthwork. And then it's got our existing survey elevation. So if I wanted to know where I was earthwork-wise, where I stood volume-wise, I can go up to Analyze and select my volumes dashboard. Now we want to be sure that we're not, in this particular situation, we're not going to have to bring in a ton of fill or create fill by cutting in some specific areas. Whatever we need to do to balance this, we'll be able to tell right here. So I'm going to go ahead and create a volume surface, and we'll just call this earthwork. And we will tell it that we don't want to see it, so we're going to leave it a no display style. We'll select our base surface, which will be the existing ground that we had surveyed. So it's the surveyed existing ground surface. And we'll be sure that we pick our subgrade road surface. And we'll hit OK. And it gives us our cut and fill. So right now, we got lucky. If you look here at net adjusted, we're at 641.23 cut. If we needed to adjust this to allow for, we know we're going to have to bring in dirt for specific situations, or the actual design itself doesn't warrant maybe balancing, and we have to lift up the road in certain places, because let's just say in this area right here, this is around station 0 plus 420. If we look at that in our plan view at 0 plus 420, let me pan down to it. That's 2. We're going to have some sort of low point right in here. Maybe we need to raise that up a little bit so that we can get our stormwater piping and everything in there to get the water away from the road. We may need to actually drop that down a little, or move the low point. What we can do is we can edit the vertical profile so that we can place our low point where we want. So I'm going to go ahead and move my dialog box out of the way. And I'm going to split my screen into 2 screens so you can kind of see what's going on here. So I'm going to go ahead and take and split my screen in half. So on this side, we're going to look at the vertical profile. And on this side, around that station area that we were updating, you can see the contours. So you can see this set of contours here that was generated from the corridor. And we can see our earthwork calculations. So I'm going to tell my corridor, I want to rebuild automatically. So every time I adjust it, it will rebuild the corridor. So I'm going to select that vertical curve, and I'm going to move the low point to this location right here, down further so we've got a little bit more area to get underneath the road and daylight on either side. So you can see it adjusted the corridor information, plus it adjusted the surfaces, okay, just from that one grip edit. So when you think about minimizing errors and rework, this one adjustment touches a lot of different entities inside of Civil 3D. And if you can imagine trying to make sure that the labels match up and have been adjusted accordingly, this is a big help. So we can look at our earthworks now and see that the information is out of date. If we select the refresh button, it rereads the surfaces and gives us our new earthwork calculation. Now again, that dropped us down cut-wise a little bit more. So I could move this profile up, and it would create a bunch of fill right there in that area. So it adjusts our corridor, adjusts our contours, and if we refresh, it adjusts our earthwork. Now that's just a little bit too much fill, so I'm going to bring it back down to say right here. And again, we can get a lot more precise with this, but for the essence of time today, we're going to just grip edit it down and get it close. So here's our final earthwork that we're going to use for our roadway. I'll go back to one screen. So we've done a lot of work, so let's go ahead and check this project back in so that people can start to, people internally that need to use this information or need to be able to see what we're doing design-wise, they can access this information through the vault. So let's check this in. And I'll go ahead and just keep this file checked out, and I'll go ahead and add the information that we've designed. So now that we've got our roadway created and located horizontally and vertically, and we've come to the conclusion that our earthwork calculations are where they need to be, we're going to go ahead and cut some cross sections and throw them in to our model. So I'm going to go ahead and select my sample lines, or create my sample lines. And I've got a dialog box that comes up to create sample line groups. And what we can do is check on and off what we want to sample. So there's a lot of information here. I don't necessarily want to see all of it. I do want to see my existing surveyed road. I do want to see my finished grade. So I'm going to go ahead and leave my corridor on also. So this is the corridor. Here's my finished grade at the top. And I'll go ahead and take off the subgrade for right now. We'll go ahead and set our code set style for our corridor so that it looks nice. And we'll change our finished grade to a finished ground style. And then it asks me where I want to actually sample. So I'm going to do this in bulk. I'm going to do it by a range of stations. And I'm going to tell it I want to keep a 20-meter width on the left and right swath width. And we're just going to go from the beginning to the end of the horizontal alignment. So I've got an additional sampling that it will take at the start and the end. And I could actually take it even further down at horizontal geometry points. And if we had super elevation, it would give us samplings at the super elevation critical stations. And hit enter, and you can see that it sampled our alignment. Now, we've got it sampling more on the north side than we do the south. So again, we can quickly edit this. So if we go to our sample line group properties and look at our sample lines, you can see I made a mistake. I've got 20 meters on the left and 50 meters on the right. So I'm just going to group select all of the samplings, and I'll change the right offset to 20. Hit apply and OK, and everything is the way we want. Now, if you think about how you generate cross-section sheets the way you're doing it now, I'm going to show you a method to bring these cross-section sheets in, and it will we'll be able to automatically create our production sheets whenever that time comes. So I'm going to go ahead and create multiple views here of my cross sections. and we'll just accept the defaults. They're all, we want it to go from the beginning to end. I'll make sure I pick my road section view style. This is the way that the cross section the section view will actually be shown. I'll hit next. We're going to use a production placement style. So it's going to read a template and actually build them as if they're going into your title block. Now, obviously, I don't have a company title block, so we're going to use what is out of the box today. We're going to bring these in at a 1 to 500 scale. And we can just accept the defaults for the rest of this. Hit create section views, and I'll pick up here above my profile, and it will create those section views in this drawing. So from the style, or how I have that built, that's how it's generating the cross sections inside of the sheets. So we could actually go in and modify this to add more sections to one page, and maybe delete the amount of pages or take off one of the pages, like this one particular one here that shows just a page that's got one section view in it. We could adjust this to where these kind of are dispersed a little bit differently, but for today it'll be fine. So here's our cross sections. This is what we're showing in the section view. So you've got your corridor, we've got our surface, our existing ground surface, and we've got a couple of labels here. We can add labels for the sidewalk, labels for back a curb, station and offset wise. There's a ton of different ways we could label these cross sections. What I want you to understand is that these sections are directly tied to that profile. So if I zoom in to that same area, all right, so that was this area here where the first low point was. And again, this is where our vertical is set right now. So again, I showed you earlier that this vertical, if you grip edit and change, it adjusts the corridor and the vertical elevations and the contours inside of the corridor just from a simple grip edit. Well, what happens to the cross sections now? So that's at about station 0 plus 46 or 0 plus 460. So I'm going to split my screen again. What we'll do is we'll zoom into that same area, but we'll be looking at it in cross section view. So that's going to be around this area right here. So right now we've got just a little bit of fill, okay, so that I can show you what I'm talking about, and it makes sense. I'm just going to grab the vertical profile, and I'm going to move it down inside of my profile view. Now watch the cross-section view there on my right. This is the dynamic functionality of Civil 3D. So that one change in the vertical profile, we don't have to worry about whether it updates the cross sections or not, because it's dynamic. It's tied directly to that vertical. So this is being driven from this profile. And we told it as much whenever we generated the cross section views. So again, this also affects our volumes per cross section. So I'll go ahead and move that back up, and it will update all of the cross sections again. I'll go back to a single view here. So now that we've got our cross sections in, let's go ahead and we can start to look at some volumes, some volume calculations. And when I say volume calculations, we've pulled an earthwork calculation of where this road sat vertically according to the existing ground. We can get a little bit better idea of how much what the quantity would be for, say, the pavement by going back to the Analyze tab. And we need to compute some materials. So if we compute materials inside of Civil 3D, we can change our takeoff criteria to a material list. Now, it's going to pull this volume from the corridor shapes. So this is key whenever you're designing a road to get volume information for your road pavement. There's actually different levels of pavement. So you might have two levels of pavement, one being the top course and one being a base course. Then you've got gravel, so on and so forth. So we're just going to map 3 different corridor shapes today. One will be for the pavement material, and we will pick pave 1. One will be for the base material. We will pick the base, the new road base. This is coming from our assembly. And we will pick the sub base and select OK. Now, once it's through computing materials, we'll be able to drop a table in here that represents which one of those 3 that we want to see. So let's say that it's pave 1 that we want to see. So if I go up to material volume table in the same tab of the ribbon, and I'll just leave most of this default. I just want to be sure that I pick the correct material list, and I can select pavement for my material. I'll select OK, and I'll stick that table right there. Now, that kind of dropped into where we were at here with our cross-section views, and we don't want that to show up. So I can just move those up just by simply grabbing it. And you can see that you have your volume for pavement. Okay, again, what if? There's always what ifs. There's always changes, design changes that come, and they come at a very inopportune time, meaning they come whenever the project is finished. And you might get that review letter that says, we've been looking at the classification of road, and we need a thicker pavement section there. Well, that presents a problem whenever you talk about minimize errors and rework, is we have to now update the pavement thickness and the quantities. Okay, so think about how you've done that in the past. Well, I'm going to zoom back up here to this area right here so you can see the actual table. And on the right side here, I'm going to zoom in, and we've been told that the pavement thickness needs to change from 0.025 meters to 0.05 meters. So I'll hit apply and OK. And what it does, it regenerates that corridor, and this is only for the one side of the lane. We can actually select both lanes and do it at once. But just so you can see that it dynamically updates these tables, after the corridor is regenerated, it gives you new volumes. Okay. I know that if you've ever had this problem in the past of the pavement thickness changing at the last second, which it happens, or maybe the road pavement gets wider, okay, that affects everything. So if the pavement lanes need to actually get wider, that's going to affect our quantities also. So if I select the two lanes, I right click and I go into the properties dialog box, I can change both of them at the same time. So I can go ahead and say they may need to go from a 6 meter lane to a 7 meter lane. I go ahead and tell it it's a 7 meter width. It adjusts both of the lanes and rebuilds the corridor. All right, you can see that it did if I zoom back a little. And then if you do a simple regen, it updates the tables, the quantity tables. So again, it not only updated the quantity tables, but we made a change horizontally. So it also updated the corridor. So the corridor itself actually got remodeled to reflect the lane width change. So again, dynamic functionality and the fact that the labeling and everything is updated is a huge thing when I say dynamic. Now we want to add some pipes. So I'm just going to do this real quick. You'll probably be a lot more precise whenever you do it. So I'm going to create a pipe network. We'll just call this storm. And we'll use our stormwater parts list. We will have it stick the top elevations or the top of the structure elevations to our new road surface. We will have it read the new alignment. So whenever it gives a station and offset, it will show that inside of the label itself according to the horizontal control of the alignment. And we will just leave these two label styles set. All right, so I want to pick a junction structure. I'm going to use one that is, say, 3,000 millimeters by 2750 millimeters. And I will use 150 millimeter concrete pipe. Now, I want to be sure I'm setting these in correctly so my pipe is showing that I'm going downhill. So I want to go uphill. So the low side of the road is over here. This is where we're daylighting. So I'm going to go ahead and just start adding pipes and structures on this side. So I'm just going to, just for today, just going to eyeball where we would put these in. So I'll just pick a point and it sets my inlet. Pick a point on this side, sets another inlet. And let's start to move maybe 100 meters up. So we'll get close here. And we'll get close here. And then I'll go ahead and add a head wall. All right, so we will add a head wall. And we'll go ahead and leave it the 150 millimeter pipe. Say we'll start off by daylighting here and then tying to this structure here. So it adds in the labels in plan view. It will also add the labels in profile here in just a second. But I can kind of move these around so you can see. We've got a lot of control with these inlets. So if I grab that inlet and I can rotate it around to where it is running parallel with the face of curb. Now, I don't know exactly from the line work. Maybe I'm having a problem recognizing where the actual back of curb or the sidewalk is or something to that effect. I can actually go in and select my corridor and go to my corridor properties, and I can change code set styles so that it will read my line work the way I want. So the actual line work itself, how I want it to be represented in my plan set, will show up correctly. I can hit apply and OK. So then I've got hatching to represent the different features. So my sidewalk, my curb, my pavement, and you have full control of this. You can build this as a style and everybody would be able to use it. So now I can actually see, if I can grab that and move it down. So first things first, this particular pipe here, let me move this label off. There's 15.2 meters of pipe between these two structures. If I grab this structure and move it to where it's represented correctly at the back of curb, there's a finer way of doing this, but we're just going to grip edit for today. All these labels update. So now there's 17 meters of pipe. Same thing if I move this structure to the other side of the road, or actually just keep grip editing, my distances all update. I can go down and I can change how my head wall is being shown. So I can make it perpendicular to the pipe itself. And I'm ready to now throw this information into the profile view. Now again, you can actually create a style that will label it for your plan view because you may not have as much information in the plan view as you do the profile, but you can create a style for that plan view and the profile view so that they do look different. So let's get this pipe information into the profile. So if I select one of the pipes and one of the structures, all right, so we're going to start to make design decisions on whether we've got these actually located correctly along our roadway. So we're going to want to be able to see this in profile view. So I'm going to, once I selected a pipe and a structure, I'm going to tell it to select similar, and it'll pick all of those pipes and structures. And then I'll tell it to draw the parts in profile view. I'll move over to my profile view and I'll select the grid, and there are the structures. And notice that the profile is again dynamic. So if the datum is not set correctly to where it can actually show this information, this pipe information, it will adjust the profile up so that you can see it. Now, I can label these pipes, but what I really want you to see, and again, this shows the dynamic functionality of Civil 3D, and this is key. What if I have these put into profile view and they move? I'm going to split my screen one more time, and I'll zoom back in on this side so that you can see. And I'm going to zoom into the plan view where I've got my pipe shown. So I'm thinking that I can actually move this pipe further down the road because it'll be able to collect the water because our road's so flat. So I'm going to grab that inlet and I'm going to move it down the road. Notice that it updates the profile. Now, let's take it one step further. I want these pipes to my cross sections. So let's do just that. Let's go to our sample line collection group and let's tell it that we want to sample more sources. So now we've got our storm pipes. We can just add those to the sections. Let it go ahead and populate here. Now once those are added, remember our stationing was at about 0 plus 400. If I look at that cross-section view for 0 plus 400, there's my pipe in my section view. Now, let's look back at our plan view about the stationing range that we're at, and we go all the way back to 0 plus 300. Now, if I look at my section view for 0 plus 300, and again, this is showing dynamic functionality. Right now I see a pipe. Why do I see a pipe? Because that's crossing my sample line. If I was to grab that inlet and pull it back to where the inlet showed crossing at that sample line, then my structure shows up. What I'm trying to show here is that not only does your plan view update, but your profile updates, because these structures would move. I showed it earlier, and everything updates in the cross sections. So literally, I guarantee this is a scenario that you've had happen. You get all your utilities and everything designed and pushed to the right location, and something happens and one of them needs to move. Think about all the places that is touching, meaning that inlet right there. It's going to be shown in cross sections. It's going to have its own alignment and profile most likely, or at least in some companies it would. It's going to be updated in the profile view. If these were already in design sheet form, we would have to go in and actually hand check where those pieces and pipes have moved to make sure that it reflected the actual design, the new design. Now we need to go ahead and check this into the vault also. So let's go ahead and check in our drawing, and it's going to take all the information. Go ahead and include my earthwork surface that we've actually added. We added those pipe networks. Now, why would we want to do this? Again, this is so that people can see, other people in your team or other people that you're collaborating with in-house can see the changes that you're making while they're designing another piece of the puzzle. Somebody might be relocating a sewer line that's around this new roadway profile. There's 100 different scenarios I could give you. So we will check that in so that they have access to that information. Now they have access to that information, but they can also see when you make changes. So if you move one of those inlets like we did just a bit ago, then they would see that update in their drawing. Now let's talk about plan production. We have generated this set of sheets for our cross-section views. So I want them to be in a set of layout tabs so that they're in final plan set form. So I'm going to go up to output and I'm going to select create section sheets. Now we have the one dialog box here for everything we're going to do, and we're going to leave all of it default. It's going to create a new sheet set for us, and it's going to also manage that sheet set inside of the vault. So we'll go ahead and hit create sheets, and it says we need to save, so we'll let it go through that process, and it created a set of sheets for us. So if I pick section sheet 21, you can see that it put all the section views according to how it had them laid out in our model into a title sheet. Now this is the first sheet. Let's look at the second sheet here. So again, we see everything that we had inside of our model, but these are final sheets. So that quickly we created a number of sheets that we can start to plot and look at preliminarily in design, or these can be your final design. So let's go back to our model, and we can actually have it create plan and profile sheets using the plan production tools. So I'm going to create some view frames so that it knows where to go along this alignment. Select the defaults here. We want it to be a plan and profile. We're going to use a 1 to 1000 scale profile sheet. We're going to keep everything along the alignment, the view frame placement. While we're doing this, I want you to be thinking of how long it takes you to generate plan and profile sheets if you're doing it just by creating a layout and then inserting your title block, so on and so forth, or just the current method that you use now. We'll leave these default, and I'll select create view frames, and it generates my sheets. Now I have a little bit of functionality here with these, so I can actually move it up and down the alignment, and it will rotate according to how that alignment is laid, and I can actually rotate these view frames too. So let's go ahead and generate the sheets for our plan of profile. So I'm going to go back to output and I'm going to hit create sheets, and we'll leave everything default. We'll do all the layouts in one new drawing, and it's going to add this to a sheet set. Go ahead and leave all this default. One thing I do want to do, I want to go through the profile view wizard here and just make some changes. I'm going to change these settings to full grid, so I use the profile view style I want to use, and we'll say that we want to split the stations at previous major grids. And we do want it to show our stormwater. We'll hit finish. We got another step here, and it again shows us what data references it's going to create. We want to be sure we pick everything that we want it to update whenever you generate your sheets. So we'll say the existing surveyed surface and our new road surface. The rest of it should be selected. We'll go ahead and select our pipes, and we'll hit create sheets. We do have to save, and it asks us for a location for the profiles. We'll just stick those underneath the other one. And as you can see in this process, it is adding these files to the vault. So we'll go ahead and hit OK. We'll go ahead and tell it yes, we want to save and continue. And the process is complete. So now let's take a look at the sheets that it pushed to the vault and see what it cut for us. So once we've opened that drawing that we pushed all those sheets to, we can see that we have our plan and profile. Now, I just want you to, again, remember how many steps this takes at your current process if you're not using the plan production tools. If we had 35 plan production, or actually 35 sheets that we were going to have with plan and profile, you would have to do each of those one at a time. So you'd build a viewport for the profile, viewport for the plan in one scenario, and you would actually have to copy that layout to the inside of the drawing and then move it along so that you could represent the station range that you wanted for each sheet. This cuts them automatically. So again, you would have to go back in and label some things, but it's very minimal as compared to having to do all of that one sheet at a time. So let's bounce back over to our overview model. So in closing, as you can see, AutoCAD Civil 3D is a powerful design tool. Again, this was an overview of the tools that you would use for a roadway project. Even in this short amount of time that we've been together today, I believe that the benefit of dynamic design has been shown. The same set of tools shown today can be used for residential and commercial site development projects also in the same manner. I want to thank you for taking the time today to watch this presentation and hope that you have a great day.